Today's topic is traveling sales problem using Hungarian method. So, today guys we are going to know about traveling salesman problem, that is using Hungarian method. So, traveling salesman problem, there is a optimal condition for it. That is, we should reach optimal condition, that is number of rows should be equal to number of zeros. That is, here is zeros are equal, number of rows also equal. So this is a from points and this is 2 points. So from points and 2 points are called as source and destination. He should go, he should, if he starts from A, he should go from A to, again he should end up with A. He can't end up with other variable. So we will see the problem. This is the example problem for this. So these are the values for the points of this. We will go to the steps of this. So step 1, basically we should calculate the row minimum. 0 means nothing but a infinity in the last slide. So infinity we will replace it. In A row, the 25 is the row minimum. And in B row, 25 is the row minimum. C row, 15 is the row minimum. D row, 65 is the row minimum. Now, we will go and subtract each and every row with the corresponding row minimum value. So, the values obtained is this. Then we will calculate the column minimum value. That is, according to A, B, C, D column, we will calculate the column minimum. After calculating the column minimum as well as row minimum, we will subtract both, but here I have taken the separate step for it. We will subtract the column minimum with corresponding columns. So these are the values we obtained by doing those two steps. Now we will go to the next step, that is row scanning and column scanning. Column scanning is nothing but scanning is nothing but finding the zeros and striking off or ignoring that row. We should get a optimal condition. For this, we should reduce it. We should minimize it. So we will see how we will do it. Row scanning, we will see each and every row we will chuck the zeros. Here there is a condition, that is we will chuck the zero. Wherever the double zeros are there, we will ignore that row. And another condition is, if we find a single zero in a row, we will strike off that column, not the row. So in this table, we have strike off one. In first row, there is double zero. We have ignored that row. So basically, we will go from the first row. In the second row, we are having 0 in the D. So we will strike off this D column. And we will ignore this for the whole problem. And there is no zeros in this row and in this row. In this row, we have 0 in this D column. So we will strike off. Sorry. There is a problem actually. Sorry. Next step is another row. We don't have zeros in any of the row. We have zero in this row, that is in the A place. We will strike off this column. Next we will do column scanning. Column scanning is nothing but we will search for the zeros in the column. In this column we have zeros in the B and A row. So we will strike off this row. As there is no zeros in any other columns, we are finished with this step. Next, find the minimum and add the intersecting points with that and subtract, which is not strike off. So wherever the intersecting points are there, that is this 2 points, we will add with the minimum value what we get in this 4, that is 10. 10 is the minimum value here, so we will add with 20, and however this is infinity, so we will strike off. We will leave it off however it is. Now we will do again the column scanning and row scanning, that because we haven't reached the optimal condition, so we will repeat the step 4 again. So we will do again the column scanning and row scanning. In this step, we have done column scanning and row scanning again by adding and subtracting. See here, we have added the 10 for 30, 10 for infinity is nothing but infinity. We will subtract each and every element in this. See here 15. 15 because 10 minus 25 is 15. 10 minus 75 is 65. 10 minus 15 is 5. 10 minus 10 is obviously 0. So now again we will do the column scanning and row scanning. Row scanning, in this row there is already double zero. So we will leave it off. In this row we will again get the same 0. So we will mark it as red and we will strike off this column. So in any other rows we don't have any zeros. Because we have 0, double zero, so we will ignore this row. Again the same step. Column scanning. In column A there is a 0. So we will strike off that row. In column B we have the 0. We will strike off this row. There are no any other zeros. So we have reached 3 zeros here. So we have 4 rows and 3 zeros. That is not equal. So we will again do the same step, adding the minimum into intercepting points and subtracting which is not strike off. That is I will show in the next table. So in this we have done. Again we have done. See, in this we have minimum value as 10 again. So we have added for 10 as 40 and it has become 55 and it has become 5 as 15 minus 10 is 5 and we have become 0 here. Now again we will do rows scanning and column scanning. In this row we have 2 zeros, we will ignore. In this row also now we have 2 zeros, we will ignore this 0. And in this row we have a single 0 and we will take this 0 and we will strike off this column. And in this row we have double zeros and we will ignore it. Now we will go to column scanning. In this column there are double zeros, again we will ignore. In this column we have 2 zeros, again we will ignore, and in this row, in this column, we have only single 0. So we will strike off this row. Because we haven't reached yet the optimal condition, we will again do the row scanning and column scanning. That is, we will do again where are the zeros are there, we will go and do the row scanning and column scanning. In this row we have 0 here, so we have strike off this column. In this row again we have this 0, as there was a double 0 we have strike off this column already, so there is no need to take this. So only single 0 is there, we will strike off this column. We have reached the optimal condition. So it returns to the optimal condition solution. We can calculate the total cost. Total cost is nothing but wherever I have marked the 0, that is in red, we will take the original values of it and we will add and total it. That is a total cost for a salesman to go. So here I have written how the salesman goes, which is the path from A to C. C is 0 here, again C to D. D is 0 here, D to B. B is 0 here, again B to B, again 0 is 0. 0 is here. So basically B to A. Basically it goes and comes back. So total cost of this is 200. Thank you. We will meet in the next session.